Hello, thank you for joining the first Google Programme virtual meetup focusing on disaster management. I'm Sam Atkinson, the General Manager of EO Data Science, and I'll be your host. EO Data Science is an Australian company specialising in operationalising Earth observations to answer specific questions. We're fortunate to have an excellent working relationship with the Google Earth Engine team, and we are even more fortunate to be providing support to the GEO-GEE Programme. Our vision for these meetups is for projects focused on similar or overlapping themes to share knowledge, ask questions of each other, and to build their professional networks. So travel and conferences are nearly impossible due to COVID, but we want to enable as much sharing of ideas as possible. With this in mind, the structure of this meetup is like a panel discussion. Each of our projects will present for 5 minutes with 2 minutes of questions and answers. Then we will take the opportunity to ask as many questions of the panelists as possible in a moderated conversation. To ask a question, please use the comments box. And please do ask questions and ask them at any time. We will get to them and put them to the presenters and the panelists as much as we can. It's really important that your questions are being put to the panelists as well, not mine. Mine are likely to be boring. Yours are likely to be very relevant to everybody else in the audience. The GEO-GEE Programme has an amazing global reach with projects on every continent. And yes, that includes Antarctica. In these meetups, we're celebrating the diversity of objectives and methods, perspectives and people that you can only get with a global conversation. As we engage in this discussion, I feel it is this diversity that offers us all the greatest opportunity to learn and share knowledge. To enable networking from these events, please look at the speaker and attendee bios that you would have received a link to in the invite to this meetup. If you haven't created your own bio and still want to, you still can. If there is a bio you see and you want to talk to that person, please reach out to them, develop those professional networks and exchange ideas. In this meetup, our presenters and panelists are Charles Huyck from ImageCat in the USA, presenting an open critical infrastructure exposure for disaster forecasting, mitigation and response. Piotr Zaborowski from Eversis in Poland, presenting their fire danger warning system. Ganiy Agbaje from the African Regional Centre for Space Science and Technology Education in Nigeria, presenting on multi-scale flood monitoring and assessment services for West Africa. Solofo Rakotondraompiana from the Institute and Observatory of Geophysics in Madagascar, presenting on flood monitoring. Mohamad Hossary from the United Nations Economic and Social Commission for Western Asia, presenting on the UNESCWA initiative for monitoring disaster impacts on land cover in coastal zones of Egypt. And Yifang from the KTH Royal Institute of Technology in Sweden, presenting on their work on Earth observation, big data and AI for global environmental change monitoring. We're also pleased to have Douglas Cripe, who is the Senior Scientific Advisor at GEO, and also Noel Gorelick, who is a Senior Engineer with Google, join us. Noel, would you like to say some words from Google's perspective?
Sure, thank you. Hi, I'm Noel Gorelick. I'm one of the co-founders of Google Earth Engine. We here at Google are excited to be able to support these projects with Earth Engine resources, but our platform is still evolving, so it's plausible that the projects are going to hit scaling limitations or want to do some things that the platform currently can't. So I'm here to see if there are common themes about back-end infrastructure that we can modify to unlock the potential in these projects. I'm just a listener and looking for insights on the projects. And with that said, I'm excited to hear about them. Thank you.
Thanks, Noel. Now let's hear about GEO from Douglas Cripe.
Hi, thanks, Sam. So again, my name is Doug Cripe. I'm at the Secretariat for the Group on Earth Observations, and as the title of this program indicates, this is GEO-Google Earth Engine. So I'm here to tell you just a little bit about GEO. GEO, the Group on Earth Observations, is a global partnership of governments and organizations that envisages a future where decisions and actions for the benefit of humankind are informed by coordinated, comprehensive, and sustained Earth observations. So GEO, the best way to think about GEO is as a partnership of governments that work together to achieve these particular objectives. Next slide, please. Our mission is to connect the demand for sound and timely environmental information with the supply of data and information about the Earth that's collected through observing systems and made available by the GEO community. So in so doing, GEO works to unlock the power of Earth observations by facilitating their accessibility and application to global decision-making within and across many different domains. So there you have the vision and the mission of the Group on Earth Observations. It was founded in 2005. We have over 100 member governments that are now participating in GEO, along with also almost 100 different participating organizations, such as the many UN agencies, such as the WMO, UNEP, and so forth. And so I'm very excited to hear what you all have been doing with the GEO Google Earth Engine program. So back to you, Sam. Thanks.
Thanks, Doug. Glad to have you here with us. Now let's move on to the presentations. First, we have Charles Huyck from ImageCat in the USA, presenting on open critical infrastructure exposure for disaster forecasting, mitigation, and response. Over to you, Charles.
All right. Can everybody hear me? Can you hear me, Sam? All right. I'm going to hope that's a yes. I'm Charles Huyck from ImageCat. We'll be talking about open critical infrastructure exposure for disaster forecasting, mitigation, and response. Our partners are CSIN and HOT OSM. This research is funded by NASA. The problem that we're trying to address here is that when critical infrastructure fails or is significantly disrupted, impacts cascade and disasters turn into catastrophes. So a good example is in New Orleans. You're looking at with the failure of the levee, you had the floods. What happens is that economies are typically more resilient than we expect them to be until they're not. So employees can work from home. Production can be recovered through working extra hours. But if you've got industrial assets or critical infrastructure that's damaged, that interrupts the flow of goods and services in a way that you've got cascading failures, and people eventually have to migrate away. So next slide, Yifang. Okay, a good example is the floods in Thailand about 10 years ago. There was just a handful of buildings that were flooded that reduced the GDP of Thailand by 10.7%. because you had flash drives that couldn't be shipped to China, you had automobile parts that couldn't be shipped to Japan, and so on and so forth. So the question is, can EO basically help to solve this problem? So next slide. The traditional way of looking at this is through supply chain analysis. It's not rocket science there. It works almost like electricity. But the fact is there's just not enough data to figure out where goods and services are flowing from any given country. It's just too dynamic. The economy is too dynamic. For a large company like Sony, if you nail down your supply chain, you have to start over when you're done because it's changed by the time you get there, let alone an entire country. So EO provides that sort of synoptic view from the top. So I'm just going to run through an example here for Thailand. Here's Thailand. It floods quite a bit in Southeast Asia. You had a lot of industrial facilities on the river, which you can see sort of to the north end of the city. Next slide. But the location data that you have for industrial facilities is sort of limited to almost like a county view. That's what Lloyd's of London, for example, has it aggregated at. Next slide. But if you integrate EO data, you can do texture analysis and so forth in a way that makes the industrial facilities sort of pop up based on their luminescence compared to the population and the coverage of urbanity. So we've got these sort of red sections here. We run a classification algorithm on that. And next slide. we've got these areas that pop out as cyan here. And next slide, you can start to overlay those with flood and figure out where you might have potential problems. And next slide. The luminescence of the infrared band also really indicates where you've got the most economic activity. And this has long been established that you can use night lights as a proxy for economic activity. So if you, once you have that risk associated with those areas affecting the potential GDP production, the question is, can you put those into economic models and figure out where you've got that interruption of services from Thailand to Japan and Thailand to China, for example, and where that might be more severe than, say, areas like Nepal, where the earthquake, although devastating, didn't have that kind of cascading economic impact because they don't have a large export economy. Next slide. And so I guess I'm just going to run through an example of the risk. Let's go a couple more slides here. We've done a pilot application using our industrial facilities in our insurance application. Next slide. And what we do here is allow insurers to enter in the amount of production they have in a given area. So this is in Tianjin, China, for example. This is where we would expect the industrial facilities to be, and it's kind of a weighted layer there. You can see in Google Maps, not Google Earth Engine. And then we overlay that with our global hazard data sets. And you can see, insurers can see where they've got potentially the most exposure to given hazards. So the point that we're trying to tie in now is how that might disrupt economic activity. And although I'm focusing on insurers here, there's a lot of applicability to NGOs. Obviously, the folks in Bangkok, who we've had that reduction in GDP, that means real jobs and real food on the table and so forth. So we have sort of a dual focus of looking at, is there things that we can do in the insurance space that would fund work that we could then present back to the NGO space to look at the objectives of the Sendai framework and SDGs and so on. And Yvonne, I think I'm going to go ahead and stop there. That was the end of my slides I was going to present.
Excellent. Thanks, Charles. That's really fascinating. I was wondering, though, looking through that, which variables from an EO perspective and also in other data sources are most important for you to understand the risk of exposure?
Well, we're classifying where we find, there's only so much you can see from the sky, right? You can't see what businesses are where, you can't see what sectoral, what business sectors are concentrated in different areas of the country. So we are trying to have a more data fusion approach to figure out, given a country like Thailand, where you expect to have the electronic services concentrated. In terms of the classification of the industrial zones themselves, the VIRS data is very important. We do use a lot of interpreted data sets from JRC, SAR data. It's really a full-on data fusion process. And one of the good advantages about the Google Earth Engine is that we can load all that data in there, and rather than having an intensive study of one little area, run it for a wider region and go and look at what the anomalies might be in different areas.
Excellent, excellent. And with that sort of data fusion approach, how do you get a handle on uncertainty in your outcomes or potential error? I suppose, how do you do an accuracy assessment when you're dealing with so many complicated data sets?
Well, that's a good question. I mean, we have done a lot of uncertainty assessments in the process, in chi-squared analysis, figuring out manual interpretation of what you see in a given area and seeing if that is reflected in the classification data itself. But in the end, what we're really trying to do is create an index, right? Figure out where, given what we see in the data, we've got more risk than another place. So if uncertainty is somewhat a constant, it's not much of an issue since we're not coming up with a number to insure things by. If we were coming up with a number to insure things by, that would be where we would have to have a stronger handle on the uncertainty. What we're really looking for is bias. Are there certain types of things that we're not identifying that we should?
Yeah.
And we're not to the point where we're able to quantify that yet, but we're hoping that we can do a wider area with the Google Earth Engine. We can start to have manual interpretation and then see what we're missing.
Excellent. Excellent. Thank you. I'm sure there's going to be more questions for you in the panel discussion later, because that's seriously fascinating work that you're working on there.
Thanks, sir.
Thanks. And just a reminder for everybody that's attending in the audience, please use that comments box to ask questions, particularly during these presentations. I'll take like I said before, your questions will be more interesting than mine, so please put them forward. Our next presenter is Piotr Zaborowski from Eversis in Poland, presenting their fire danger warning system project. Over to you, Peter.
Yeah, hello to everybody. I hope I can be heard. So thanks for this meeting, for the organization, and for the participation. And hopefully it will be fruitful discussion. And a few words about our project, which is focused on the fires. So the focus is much narrower than the previous one. And as you probably know, the fires are not a new topic in the remote sensing area. We have plenty of, maybe not plenty, but several services that are running 24/7 days. And they detect hotspots, which is brilliant. And it's kind of starting point for us, because we believe that for the systematic approach for this disaster risk management are the predictions. Next slide, please. Thanks to this program, it will help us to scale up our efforts in the R&D. And a few words about our perspective, because we are not in the research only. We are a technology company with 70 years of experience in software services development, but only 5 years in EO. And in this area, we are focused on this processing and the dissemination of the data. We have been providing services for, as you can probably recognize the logo of Disaster Charter for space and major disasters. The services of the core system of this is provided by us, and this is also our focus at the moment. So next slide, please. And we have come up with this idea because we are observing the fire danger monitoring in our area. So this is our also starting point for this project is the Poland. As you probably know, this is country in Central Europe. And a few words about the current status quo, fire monitoring and predictions. It's based on quite good data because it's based on in situ local stations, but it has 60 zones. As you can see, the zones are quite large. There are 4 classes of the classification, and according to our validation, not necessarily the highest risk is responsible for the highest probability of the fires. Of course, there can be several reasons, but not going deeply into details of this. We can also see that some of the areas are not covered, and the southern area of Poland, which are mountains and forest grasslands, is not covered at all. We have also some missing data because of the outages of the local stations, and we have also quite rare calibration of this model. Next slide, please. So our response for this change is based on 3 pillars, and it's proved on the research level by several papers. You can find this in the captions. And first pillar is the fuel. So what is the coverage of the area and what is the state of this, the vegetation and season probably. Second one is draft and monitoring of the draft, which is increasing problem in our region, and meteor data, which is the forecast data and current station of the temperature, cloudiness, and winds. Next slide, please. So we have identified most of the data that is available on Google. Only a few of them that possibly can be used in this model, which is Sentinel-3 and SMOS, is not available. So probably we will ingest this data as well from available openly accessed DSS or CHAP, but most of the rest of the data is available. And according to the research, the logistical regression is quite good. And we'll start from this. In plan, we have also the other algorithms to be tested for the reference and to choose the best approach. But this will be done in the next phase. So next slide, please. We have already identified several challenges. So Poland area is quite fragmented. There are a lot of plots that are even smaller than the resolution of the remote sensing data. Probably our coverage model will be not so discrete. We don't have very precise classification of area. The second challenge is the applicability of this model, because our approach is that we'll try to applicate this model to similar regions, I mean similar climatic zones, but maybe it will work on the other regions as well. And as always, probably we have the ground truth accessibility and the quality. So we have the administration data for Polish region. We have also this viewers data and hotspots that are already provided by the services, but of course they have to be masked, and there are a lot of positive, for example, data that can harm our quality assessment. And as we know, there are efforts in Copernicus, for example, to provide in situ data for larger coverage. So this is also something that we are most interested in. Next slide, please. So we have 4 milestones in the project. Currently, we are working on the data ingestion, because apart from the remote sensing data and the prediction for media data, we are ingesting also the administration classification of the land and validating the remote sensing derived product of the land classification against this administration data. It's brought us some ideas already, and putting this into logistical regression, as mentioned. So the next step is challenge with, not the next slide, please. Next step will be the assessment of the other machine learning models. Then we have the validation of the users from public and commercials, and then try to assess this model in other areas. So yes, if you can switch to the next slide, maybe it will show you the outcome of our classification and the accuracy of current model. So as you can see, a lot is to be done, because as you can see, in most of the regions that we are interested in, so in the grasslands and forests, the current model is not giving right answer to the prediction. So that's all from my side. And questions?
Thanks, Peter. Really fascinating work you're doing there. I did have a question, noting that nobody in the attendance has put one through for me. I'm waiting, guys. So I noted that you're using a number of in situ data sources, weather stations, soil moisture monitoring, etc. How robust is your system, or how do you plan a system to be robust when there is the potential for one of those in situ stations to fail or stop communicating for a period, or I'm interested to hear what we can learn around how we make a broader system robust to those sorts of individual failures.
Yes, as you could see, the regions of this meteor station is also not so dense. So there is also missing data in between of this. And that's why we are working with this remote sensing data, because the current model that is based on the in situ data doesn't give us the robust prediction of the fires. And that's why we are trying to merge these approaches and also based on this remote sensing data, which should give us something like 10 kilometers resolution only through remote sensing data.
Excellent, excellent. And a question from Alexander. Have you published any articles about that project you're working on?
No, not yet.
Not
yet. Hopefully it will appear something in next year, but stay tuned.
Yes, excellent. No, I understand, working for a private company as well, that yeah, papers can be time consuming and at times a distraction from the work you're doing. Excellent. So one last question. How do you plan to put this information into the hands of decision makers, and what processes are you going through there to ensure that you have the impact on ground?
Yes, so of course we are trying to, and we are consulting this. So in this first milestone, we have the survey with potential users, also from public administration. And of course, we will present this in several panels. We are working, as mentioned, also with the charter, so maybe there will be a chance to and the interest from their side. But obviously, it's not easy task, because the official administration is following the their own agenda, and there's a long way of populating, evangelizing, and so on to make them aware of the potential and, of course, about the value that can be provided by this kind of model. So not necessarily this has to be included in the official strategy for the fires, but it can be helpful for local stations. So that's our approach.
Excellent. Okay, I appreciate those insights, and thank you very much for sharing your project. Looking forward to asking more questions of you in the panel discussion later. Our next presenter is Ganiy Agbaje from the African Regional Centre for Space Science and Technology Education in Nigeria, presenting on multi-scale flood monitoring and assessment services for West Africa. Over to you, Ganiy.
Yeah, thank you very much for bringing us to this forum. Really appreciate that we bring in everybody to this particular meeting. Yeah, the African Regional Center, the next slide, please. The African Regional Center is the next slide. Hope you're hearing me. Yeah, is one of the United Nations Office for Outer Space Affairs Regional Center for Space Science and Education. There are 6 all over the developing countries and regions in the world. We have mainly focused in the space education, and also carry out outreach program, and we also do space research and innovation. The next one, we've had quite a number of students since 1998. We've been running the next slide, please. We've been running the PGD program, the postgraduate programs. Recently, in 2013, we are now running the Master of Technology program in collaboration with one of the universities in Nigeria. The mandate covers about 25 English-speaking countries in Africa. There's another one also located in Africa, in Morocco, which is taking care of the French-speaking countries in Africa. We've been doing well with regards to the number of students being particularly using Earth observation data and other space science education to improve the awareness of using the technology to improve the well-being of the African countries. Next slide, please. This particular program is an initiative of the collaboration of the African Union and the European Union, which is called GMES, Global Monitoring of the Environment. and security in Africa. This particular project is about the flood monitoring and assessment in West Africa sub-region. We are one of the consortia that won this grant to look at the flood monitoring as regards to monitoring, assessment, and to manage the flood using near real-time Earth observation derived information. So that we can help to improve services such that we improve preparedness and response and post-disaster phases of flood. We intend to establish, which we have started with, updates the flood event database, improve the capacity of disaster monitoring organization. Next slide, please. Next slide, next slide. These are the partners and their location. Next slide. Next slide. These are the locations of the study location based on the various areas in the countries. Since we are looking at riverine flooding, they are based at various basins in the countries. We intend to actually develop, as I said, a flood event database which is updatable and be able to forecast flood and carry out some kind of assessment, establish image acquisition and processing analysis using readily available data, especially from the Sentinel, to map flood extent and also provide information before and after the flood event. And also we carry what we call the damage assessment model. Next slide, please. Next slide. Yeah, this is the methodology in brief. We intend to, well, it has gone well. We intend to have about 4 or 5 products of flood forecasting, which may be through SMS. Well, okay, go back to the methodology again. We'll be having Earth observation data, which then carry out processes, flood forecasting, flood event mapping, damage assessment. Then the products in, like flood hotspot maps, extent flood maps, some alert services. And mainly we'll be carrying out capacity building for national meteorological agencies, disaster management organization, the academia, the students, all these to help in strengthening their capacity. Next slide, please. Next, yeah, the products we intend to get out of this project is about flood forecasting. We'll be getting to the main target audience, which are the such as sorry about that. Right, we're trying to look at how we can get to the farmers, those who are really affected. By getting to them, we'll be able to alert them how best to, when to plant, when not to plant, when to move away from this kind of disaster. The next slide, please. Next, we'll be looking at forecast maps. Will be our email or the website is as shown on the website. We can see a lot of information from there. Next slide. Well, in summary, the aim is to enhance the efficiency of the flood monitoring and assessment and management in this sub-region using Earth observation data. So that we believe the benefits to the people is to provide the tools, the models, the databases, and system to enhance the information and knowledge base of the respective disaster monitoring organization. We have them, but they need to adapt to using EL data, and through tailor-made trainings, the project will possibly impact on the technical expertise of these organizations. And we hope to make impact by engaging the GE technologies and compute services to generate products through the various available application program interfaces, that is APIs in the GEE engine. Thank you very much.
Thank you, Ganiy. Very interesting. And a couple of, I suppose, observations from my point of view. I note at the end you talk about the challenge of convincing potential users of your insights or educating them in the use of Earth observation data. But I think that really ties back very well with one of your earlier slides, talking about the number of postdoctoral positions that is being supported in West Africa in the use of Earth observation. I think they tie it together really well for future use of Earth observation data. So congratulations to you and everyone else contributing in that space. Are you planning to rely, I suppose, mostly on Earth observation data, or are there other data sources that will contribute?
We're actually combining both Earth observation data with other traditional data we use in forecasting. So, but we know that with using Earth observation data in real time, it can capture where there is a major problem with regards to riverine flooding, and we'll be able to predict in real time. Because we intend in between to use the charter. In case there's any issue, we can deploy the charter and be able to get more information, and then it will go into our event database and quickly predict or do what we call real-time prediction to assist with regards to disaster monitoring organizations. So we are combining or using the Earth observation data to improve what they are already been done. That is already been done. What we have found out so far is that we've already had what we call collaboration with the relevant stakeholders in various regions, and we'll be able to access their data. And with that, we are trying to even build what we call a database, national database, apart from the regional database, so that they can key into it. At the end of the day, they are to own it and use it as a tool for prediction. And we believe that there will be a common ground for the region to be able to do the same thing in a better way.
Excellent. That's a great answer. It really answers my next question of how you plan to put the data or put the information into the hands of decision makers. So that's excellent. I think we've got time for one more quick question now. How do floods manifest in Nigeria? What are their main impacts? I know there's parts of Nigeria which are very heavily populated. Are they the most vulnerable to flooding, or does it relate more to farmlands and crop production in other areas? I'm interested to understand in Nigeria and West Africa, what are the key impacts that floods have?
Wow, that is a very big issue, because especially the riverine flooding, the major, as the developing countries, the poor or they rely mainly on agriculture, and then if they don't have information about what is happening, or they may not know what is happening at a particular area of a particular river coming into the country. Look, for example, River Niger comes all the way from Futajalon and coming down to the delta in Nigeria. You can see that there can be some activities going on upstream, and the farmers in Nigeria may not know what is going on. There's need to really inform them. This is going on. Next year, there's going to be this problem, there's going to be that problem. And then to also alert them with regards to what is keeping your environment right in terms of not dumping refugees here and there, and that or construction of houses and others. The impact of flooding is on the environment, is on the agriculture, we can also lead to flash flood in the urban areas. So all these have great economic impact in countries of West Africa, which have a lot of economic woes. If you then leave them to be subjected to that, then it makes the community more poorer. So to be able to get hold of flooding and monitor it and be able to alert people, at least it will lessen the effect of the disaster itself.
Yeah, Excellent, excellent. Very exciting. Thank you, Ganiy. Look forward to having some more, putting some more questions to you in the panel discussion.
Yeah, well, thank you very much, and I believe that we also pick in some of the presenters. We may like to collaborate with them to get some information from them to help us with what they are doing also. Thank you.
Excellent. Thank you. Next, we have Solofo Rakotondraompiana from the Institute and Observatory of Geophysics in Madagascar, presenting on flood monitoring again. Thank you. And over to you, Solofo. Solofo, I'm not sure if you can hear me, but I think you're on mute. No, I'm afraid. Can't hear you. No. 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 Sorry. I suggest, Yvonne, that we move on to the next presenter and look back to Solofo if we can. Okay. Thanks. Definitely, Solofo. We do want to hear about your project in Madagascar. I know it is interesting, and I really want to share that with everybody else. So let's instead right now talk to or have a presentation from Mohamad Hossary from the United Nations Economic and Social Commission for Western Asia, presenting on the UNESCWA initiative for monitoring disaster impacts on land cover in coastal zones of Egypt. Over to you, Mohamad.
Thank you very much, Sam. So my name is Mohamad Hossary, and I work with UNESCWA. And with me right now are my colleagues, Dr. Wafa Abul Hassan. She's the head of the project and the supervisor. And also my colleague, Rafi Shirinian. He's the data scientist in the team. Next slide, please. Thank you. All right. And so I already mentioned Wafa and Rafi. We also have Muhammad Abdullah. He's also a very talented data scientist, Marlene, Christoph. And we also have colleagues from CAPMAS, the Egyptian National Statistical Office, which we'll get to a bit further on in the presentation. And of course, we can't forget Yvonne and Sam, who have really helped us a lot in this project. Thank you very much. And next slide, please. Right. So our project basically has one key objective, and it's to monitor the disaster impact on agricultural land in Egyptian coastal area. And so we've defined basically the coastal area to be within 100 kilometers of a body of water and around 10 meters or less. So next slide, please. And so why is this important? So as far as the Arab region goes, we have high population growth, we have natural resources, and we also have like a reliance on agricultural products, especially in Egypt, in the northern coastal area, where you notice that there's a very high concentration of vegetation and agricultural area. And so remote sensing can really help us in terms of determining, where damage is happening on a very broader scale, especially using Google Earth Engine. And so we also wanted to mention that geospatial analysis was highlighted as a key area that needs to be developed within our ASCO member countries. And they're very keen on working with geospatial data and adopting it into their countries' processes in the future. Next slide, please. And so the data that we're going to be using, it's mostly multispectral sensor data. We're looking mostly at Landsat and Sentinel data. And we're also trying to work with our Egyptian colleagues from the National Statistical Office, CAPMAS, and other actually Egyptian colleagues who they have their own remote sensing center, and they're working on projects. And so we're trying to get from them data to support this project. And we're also working with other UN agencies to acquire data and to provide, a more complete view when we do our analysis. So we're also relying on data from other international databases on extreme events. So we have data from UNDRR, the United Nations Disaster Risk Reduction Agency. They have data sets on disasters that happen worldwide. We also are using research-based disaster data from that are accumulated by universities. For example, Dartmouth has a flood observation data, while other universities, or rather other departments in other universities, have their own data sets that we're working with. And we're also working to ensure that all our data is open and freely available for everyone. And so our methodology. So like as I mentioned before, we're basically delimiting the coastal area based on elevation and proximity to a water source. We're also working on land cover areas by using our multispectral data. We're also combining that with different classification algorithms to figure out the type of land cover that we're looking at before we start evaluating the effects of extreme disasters on the classified areas. And so we'll also be mapping out these extreme events from the previous databases, the previous data sets. We're working on essentially merging them and incorporating them into Google Earth Engine. They needed some cleaning, some processing before we can actually use them. And we're going to look at images before, during, and after a certain extreme event happened to be able to estimate the damage done. We're also going to use, hopefully, data from Egyptian authorities to ground truth what our findings and essentially fine-tune our analysis to provide as an accurate image as possible. Next slide, please. And so our partners in this endeavor, as we mentioned, are CAPMAS, the Central Agency for Public Mobilization and Statistics. They're the National Statistical Office for Egypt. We also have the National Authority for Remote Sensing and the Remote Sensing Authority also within Egypt. We also have, in terms of other UN agencies who are helping us out, we have FAO, UNSD, UNOICT. UNOICT is the technology, our technology partner. We also have UNDRR. They're responsible for disaster risk and the Sendai framework. We also have UN OCHA and UN UNEP. Next slide, please. And so what we hope to achieve from this exercise and from this project, we want to make sure that our algorithms and code that we use in the project are freely available to everyone, especially our member countries. We're also working on data products that can help visualize the damage, the analysis that we do. And we're also hoping to have the set methodology available for any country that's interested in replicating this project. Next slide. And so our progress so far. So far, we've acquired the public data sets related to disasters. We've been working on accumulating them, evaluating them, cleaning them, georeferencing those that aren't really georeferenced. We're also exploring land cover. So, Sentinel, for example, has land cover mask included within the data set itself. We're working on exploring the remote sensing data that we have available. We're talking about Sentinel. We're talking about Landsat. We're looking at different. We're testing out different vegetation indices to see how each one affects our final result. And currently, we're also in talk with the Egyptian government to secure the data, hopefully, that we're going to use to ground truth. And we're going through it. We're going to hopefully achieve it through official channels to make sure it's also, and we're going to make sure, hopefully, that it's also available for the public. Next slide, please. So in the future, what we're hoping to get out of this is, we're going to develop workshops that focus on geospatial analysis and remote sensing, and how it relates to official data from that governments are currently collecting. We're also hopefully going to produce publications to help disseminate the methodology and the results that we find. And we're also going to work on developing future partnerships on remote sensing projects. Next slide, please. And that's it. Thank you very much.
Mohamad, thank you. That's very interesting. There was, a few things I really want to ask you about, but probably one that I was wondering about, and I think you touched on it a bit, but my understanding, and I could be wrong, feel free to correct me, but my understanding is the Nile Delta is a very dynamic environment. So what role does that accurate land cover mapping really contribute to how you assess disaster impacts in the Nile Delta, and how do you account for that changing land cover?
So that's a very good question. To first talk about the accurate land cover classification. So in that regard, to be able to properly evaluate the damage that's occurring within the disaster time period, so before, during, and after, and we're still looking at what is the most appropriate time period to evaluate it. We need to be able to understand what exactly is present in that location and how it's being affected by that disaster. So, for example, a flood may affect agricultural areas more severely than other areas, than maybe forested areas. Obviously, that also depends on the agricultural product that's being cultivated in that specific area. And so that's so in terms of land cover classification accuracy, that's, I think, the main point that we're looking at. And so for the Nile Delta and the shift in land cover, this is definitely something that we're taking into account. We're working on time series analysis to be able to better understand this shift, this change that's occurring within the Delta itself. And also keep in mind that the Nile Delta is just one part of our study area. So, for example, another part that we're looking at, and we've been discussing how to incorporate shipping data into it, is the Suez Canal from the Mediterranean side. So the entrance essentially to the Suez Canal from that side. And you have a very important regional port, Port Said. And that's one of the areas that also may be very affected by certain types of floods. And so that's one thing that we're also looking at in that study area.
Excellent, excellent. Thanks, Mohamad. I look forward to putting more questions to you in the panel discussion.
Looking forward to it. Thank you.
Our next presenter is Yifang Ban from the KTH Royal Institute of Technology in Sweden, presenting on their work on Earth observation, big data and AI for global environmental change monitoring. Over to you, Yifang.
Thank you, Sam. Hi, everyone. I'm here representing the EO/AI for Global Change team at KTH. We're based in Stockholm, Sweden. Next, please. Our planet is facing grand challenges from wildfire flooding, as you heard from previous speakers, to drought, melting sea ice, and melting glacier. According to a UN high-level meeting last year, only 11 years left to prevent irreversible damage from climate change. Next, please. For example, urbanization. Currently, we have 55% of the world population living in cities. By 2050, we're expecting another 2.5 billion people living in urban areas. So majority are in developing countries. Urbanization has a significant environmental impact from pollution to urban flooding and endanger biodiversity. Next, please. And wildfire, as you know, in recent years, we have experienced many devastating wildfires from Siberia to the Amazon, from California to Australia, and even to Sweden inside the Arctic Circle. Wildfire damage property, kill and displace people, and damage to animals, vegetation, and cause a lot of pollution and CO2 emission, and cost billions of dollars to fight, and also cost billions of dollars damages as well. Next, please. So we have, since 1972, we have many Earth-orbiting satellites producing huge volume of Earth observation data. And these Earth observation data provide a great potential for urbanization monitoring as well as near real-time wildfire monitoring. Next, please. As you can see here, it's optical data in boreal region in British Columbia in Canada, and the one on the right is a wildfire in California. It's the August complex fire from this past summer. And even the sunny California, there are also a lot of clouds in this area. So, and also plus night. Then you have a limited acquisition from optical sensors. Next. So with the possibility of using radar, that's the images from center to left, we're able to have a day and night observations that are not affected by clouds and smoke. So using both optical and radar data, we can try to track the wildfire progression in near real time. Whenever there's an image, we would like to be able to see where is the fire, what's the damaged area, where is the fire is progressing. Next, please. So the objective of this research is to develop innovative, robust, and globally applicable methods. So the methods should work in different cities and different wildfire conditions. Then for change detection, so it's a change detection method that we wanted to be able to use for maybe wildfire monitoring as well as for urbanization. And then we also wanted to see what are the changes, impact of these changes on the environment in terms of ecosystem services, network connectivity, and biodiversity. So this has a potential to contribute to number of SDGs, 11, and 13 and 15, as well as the Sendai Agreement, Paris Agreement, and the Sendai Framework. So next, please. So we have developed preliminary so far methodologies for change detection for near real-time wildfire monitoring, and also continuous urban monitoring. So these frameworks here I showed are using data from Google Earth Engine and and also trained through a deep learning framework, and then being able to predict the changes in terms of wildfire and urban expansion. So here are the two papers that if you're interested, you can contact us about the methodology. Next, please. So this is an interdisciplinary team from people like myself and my colleague Andrea in the Earth observation side, and we have colleagues in deep learning side, as well as a colleague from environmental impact side. So interdisciplinary team together with a variety of users from the city to the regional authority and to UN Habitat, as well as the wildfire services in BC, British Columbia, and also the Swedish National Civil Contingency Agencies. They're very interested in using the result generated from this project for support their wildfire fighting operation, as well as sustainable city planning. Next, please. So here I'm just showing you some preliminary results that we produced using EO and AI method. So this is, you can see the fire can be detected, the progression on different dates, and we're able to detect fires when it's quite small, when it's just started. Whenever there's an image, we aim to detect the fire. This is the Elephant Hill fire in BC that burned 200,000 hectares. Next, please. Next slide. Yes, so this is another example. We compare different methods. This is a wildfire near Sydney, Australia. And you can see we were able also to detect the fire on the second day when there was an image and continuously. And the fire, if the fire were contained when it was early detected, then it would have stopped a damage of 800,000 hectares of vegetation being burned, and also emit tons of CO2 into our atmosphere. Next, please. And for urbanization monitoring, so we use both optical and radar images, and using a methodology developed for continuous urban extraction and change detection. And with this kind of data, planners can look at where it's changed and how to plan more sustainably. Next, please. So yeah, so to summarize, and the project is funded by KTH Digital Futures, European Space Agency, and Swedish Environmental Foundation, as well as we're part of the GEO-GEE program, and also below I listed some of the users we work with. So thank you very much.
Thanks, Yifang. We're running a bit short on time, so I'm going to restrict myself to just one question. And it actually comes courtesy of Douglas Cripe. How does your outputs, or have you done the comparison between your outputs and the global wildfire information system?
That's a very good question. The global wildfire information system, it's used VIIRS and MODIS data. So it has a much lower spatial resolution. Of course, we have a higher temporal resolution, twice daily. But our results using Sentinel-1, Sentinel-2, and Landsat. So it's a much better spatial resolution. So this is why users are working with us. They see the other product is useful, but it's only for contextual awareness. But for more accurate mapping, they would like to have higher spatial resolution. Of course, they also want high temporal resolution whenever possible.
Yes, it's the old conundrum of wanting both better spatial and temporal resolution.
Yeah.
One more quick question from Irving, one of the attendees. How much delay is there to obtain the results from the system? Or what's that latency period?
You mean the time it takes to train the model and predict?
More so from once you have that model in place, how much time between, how old is the information when it is produced? Is it 12 hours?
Okay, no, all right. So if, let's say, if we can get the satellite data in near real time, basically it's 3 hours after acquisition, then we would, then would be able to process it. But now we use it on Google's engine. That data is 1 day old, but we try to get access as early as possible.
Yes, excellent. Thank you. Look forward to talking with you more in the panel discussion shortly. Now I really want to hear from Solofo. So hopefully the microphone is
okay. Do you hear me now?
I can hear you.
Good.
I'm very pleased. Sorry, just let me introduce you. Solofo is from the Institute and Observatory of Geophysics in Madagascar and is presenting on flood monitoring. Please, Solofo, take it away.
Okay. So good day to all. Next slide, please. So in the Indian Ocean region, we have every year we have about 1 or 2 cyclones, very important cyclones in this region, and they are not so as intense as what happened in Florida or in Philippines, but they are quite destructive, as you can see in this photo. Next slide, please. Yes, it's good. For Madagascar, cyclone might have a very strange trajectory. As you can see in this example, this example is cyclone Giovanna in 2012. So the cyclone is going through the island the first time from east to west, and then he goes back to the east. And this second part of his trajectory is very destructive during this year. So next, please. Okay, so consequence of cyclone is, the main consequence is flooding. When we have flooding in urban area, it can be identified in very short time. But when flooding is happening in a rural area, there we have a lot of problem, because during this flooding, most of the time, communication are already cut. Communication are also cut. So government cannot know what happened in rural area. So that's why next slide, please. In the future, we are expecting to have more and more cyclones. So that's why it is important that government can have a system. Next slide, please. It is important that government can have a system that allow them to know whether there's a flooded area, and as much as possible in a very short period of time. So can I have next slide? Okay, we already worked on this topic some years ago. we are using some radar images. We are comparing images during dry season and images during cyclones or just after the cyclone. Next slide. Next slide, please.
Thanks, Solofo. I think that was your final slide.
Okay, it is not important. Okay, I just can explain without. Okay, so we already worked on this topic years ago, but the problem is that calculation with radar data is always very, very important, too much important. So the method was not useful, practically not useful. So now with Google Earth Engine, we think that we can use this method, and we can also use other algorithms for flood detection. Okay, so I think that's all I have to present today. Thank you.
Excellent. Thank you, and I'm glad we did get to hear from you because I know from our previous conversations, very interesting project. One quick question before we move into the panel discussion: how do you plan to put the results of your project into the hand of emergency response services?
Yeah, we are working with the national institution in charge of risk management. So the result of this project will be used by this institution, hopefully.
Excellent. Good. That's great. Great that you have those linkages. Sometimes it can be hard. So yeah, that's excellent. Well, thank you, Solofo. Now we'll move into the panel discussion. As your host, I've allowed time to slip a little bit, so we don't quite have as much time in the panel discussion. But please, if you're watching this on YouTube, put your questions in the comments. I'll prioritise those questions above my own. But to get things started, I might ask a question and then hopefully get a quick response from a couple of you. So obviously, timely information is really critical to best respond to natural disasters and to mitigate impacts. What are the challenges and kind of what solutions are each of you pursuing to enable emergency responders to access the information that you are producing? I think that's probably a good question for the UNESCWA team. Mohamad?
I can answer. Yes, thank you, Sam. I can reply on behalf of UNESCWA. Yes, timely data is very important, and we face this problem when you deal with official data from countries. So you have to wait and wait and wait, and until now we have our partner in Egypt where we were expecting the maps from their census results, because there's a wealth of outputs from a census that provides you with information on population, categorized by age, by all kinds of disaggregation, and then also like the economic activity, like we saw in the first presentation. So this data takes too long, and when you have to combine the data with real-time data, it's really painful, and you have to you have to be patient and make compromise, because you can't leave one at the expense of the other. So Earth observation is great because it's providing us with all these monitoring, data that we can make use of. But also we see that, for example, in Egypt and in this region, like the events are different than other regions. So we have to see also how to make best use of this data in this region. And yeah, this is how we're going to go about it.
Excellent, good. And I think I've asked a similar question to many of you already. So let's change tack. And Charles, I might point this question at you. For the solution that you are developing, or ImageCat is developing, what's the most important?
Can I have a response?
Sorry, Ganiy, yes, please jump in. Sorry, Ganiy, did you want to make a comment? No, lost him.
I think he might be muted.
Yeah.
Oh, thank you very much. I just want to give a kind of solution.
Please have a conversation.
A comment on the answer given, how we're able to resolve the issue of data access. You get that?
Yes. Yep.
Hello?
Yeah. Yes, I can hear you. Do you want to make a comment on that?
Network. I'm hearing you. Can I go ahead and just give a comment on that?
Yes. Yes, you can.
Well, I'm hearing you. If you're hearing me, I can just make my comment.
Yes. Please do. Okay.
Okay, can I go ahead?
Yes.
Well, if you're hearing me, I'm just looking at the issue of data access. We know that this is going to be a major problem, and part of the task in our work packages is to ensure that okay.
Yep, we can hear you.
Maybe
Ganiy.
it's network. Maybe I type it. Don't worry. Go ahead.
Excellent. Thanks, Ganiy. Yes, of course, that is one of the challenges of virtual meetups.
Are you hearing me? No. Sorry.
Yeah.
It's a network.
Charles, so I was going to ask you, what do you feel is the most important enabling technology for the solution you're developing?
Enabling technology. I think that prioritizing.
Okay, if you're hearing, what I'm trying to say is that the solution to data access, we put it as part of our task. The task. So what we did was to have what we call data. What we had was we have in one of the tasks is to have data sharing agreements with stakeholders, which we know they have those data, because this particular project will not allow for payment for data. So we have to use Sentinel data. So we are now to make sure that those stakeholders who will continue to run the project after we finish it are stakeholders. We ensure that they are part of it in order to own it. So as a result, we sign what we call data sharing agreement with them so that we can have easy access to their data. Thank you.
Excellent. Thank you, Ganiy. Charles, please, I'm very keen to hear what technologies are enabling your solution.
Yeah, I mean, I would just point out that it's not EO data is not always
we can move on. We can move on.
Most useful
post-event. Is the network challenges.
Yeah, so I mean, you know, and prevention, so to speak. So what we're trying to do is identify problems waiting to happen. So our goal is to identify, you know, the next Tohoku, the next New Orleans, the next Bangkok, a type event that could happen. Prioritize, highlight those. If you can use the Google Earth Engine platform to highlight that potential globally, then you can work with NGOs, disaster risk financing, insurance to essentially set up financial mechanisms to fund mitigation of those facilities. And a lot of these facilities, you know, there's a lot of money behind them, right? So it's not, that's not really the problem. The problem is identifying, we don't have the ability to identify where those accidents could potentially happen at this point.
Yes, excellent. And now Peter and the Eversis team, a question for you guys. What do you feel is the primary barrier that you need to overcome to implement your system to have the impact that you want to have?
Yes, I think this question is rather on the commercial implementation, like reaching to the stakeholders side. Do you understand it correctly?
Yeah, potentially. It could be a technological barrier. It could be something else. I suppose I'm interested for us to share the barriers we need to overcome and potentially.
Yes, I think this question should be like as I understand it, it's like twofold. First is like the technological part that was already mentioned, is the question of scalability. We have quite a good access and relation here locally, where we decided to set up our test bed in Poland, Central and Eastern Europe. But the question is how it will scale up our project and our approach to the places where we do not have, as you mentioned before, in situ stations and such precise information on where the fire outbreaks. That's the first main challenge that we try to overcome by directly from the early stages, relating to the other remote sensing data sets that we can serve as proxy for instance, hotspots. We immediately jumped on that data set as a proxy for real fires. That's probably the obvious thing, but there are like many other land classification databases. We already discovered some really huge discrepancies, at least on our area, so we can only assume that it will get worse as further from our data sources we will go. Secondly, I think it's more on the Piotr side for the reaching to our customers and future stakeholders, like how we can deliver it. And maybe there's like more a psychological barrier because technology is there.
Yeah, of course, technology is there. Of course, the model has to be robust, and we have to provide quite good resolutions. Something that was already mentioned. Also, this spatial and temporal resolution. So as we get more data, it will be easier. But of course, it's a kind of change of the mindset and change of the approach. It's already promoted in some areas. So you have already the policy for EU countries and the usage of remote sensing data for the land classification. So hopefully it will be more and more popular as we'll have more and more data and the solutions, and the accuracy will be better. So this is changing, and we can see it. Of course, there's a lot of effort to be done also in the promotion, but I think it's on the way.
Excellent, thank you. Yifang, I think you're muted. Sorry.
Yes, I would like to comment on that. I think one of the challenges would be if you develop method for flood monitoring or wildfire prediction or wildfire monitoring, how that method work in local areas can be globally applicable in different climate zones, in different terrain conditions, in tropical forests to the boreal forest to the Mediterranean climate. So I think that is one of the major challenges, at least our project is facing.
Yeah, it's a very good point. I mean, that's the great challenge of scaling something globally is how do you ensure that it is still accurate locally. And similarly, when it comes to disaster management or science communication in general, how do you take a global information system and actually make that available and impactful for local decision makers? I suppose is another question. If anyone has an answer, I certainly don't. To that, feel free to make a comment.
I think it's very important to avoid false precision. When you're in the way that you put that data back out to the end users, to make it clear, to aggregate it up to the appropriate unit of analysis, or else you can make some bad decisions.
Yes. Excellent. A question for, I think I'll put this to you as well, Yifang. Because I know that you are obviously very experienced and successful leading teams of researchers, large teams, and making those teams very functional and productive. Have you got any insights on how to best manage a large team to be productive, to have the impacts that we are trying to have?
Oh, thank you for the question. I think definitely this is a very good question. I think communication is the key, and we communicate the software platforms as well as in-person meetings. We have bi-weekly team meetings, and we try to organize workshops together with the users. We try to stay more motivated because they know they're doing something impactful. Not only we just publish some papers and move on, we actually doing something that users might need or use. And also, I think to divide the groups also into some focused areas, and then more, if it's very big and different kind of people, sometimes when you talk about deep learning, the environmental impact, people are not interested. So then you will section focus meetings as well as big meetings. So really try to get people more interested and motivated working for a high impact goal.
Excellent.
So I don't know if that answers your question.
No, I think so. I'm always interested in how do you get the best out of a team of people. So I thought I'd take the opportunity while I was talking to you. Next, it looks like we might have lost Ganiy, who was going to receive my next question. All right, I'll think laterally. Apologies. Just looking down the list. Peter, there was a question from you, for you, I should say. Are you going to use data derived from meteorological stations and convert that to raster data? And in that case, how do you manage the different spatial resolutions of rainfall in situ measurements versus Earth observation data? Sorry, Peter, I was,
Yes,
it's a good question, of course, and we have this also for the validation data and for the classification that comes from the administration side. So yes, we have to make the extra interpolation for this, and it's one of the challenges as well that was mentioned, that the locality and going from this global scale to this local scale is the challenge that that we are facing. So yes, we have to provide the model that will be tested against best accuracy, as we define this accuracy. Because it's other case, how do we define this false positive, and how do we define that this prediction was good enough? So yes, this just not yet the precise answer, because we have to play with this data and to work out the approach that will be best in terms of the error, in fact, in the end.
Yeah. Excellent. I think that's an excellent answer, that these challenges need experimentation. And I think that's one of the great things about these programs, is that Earth Engine does make it relatively quick to experiment and to learn and fail quickly. So thank you. I've just realised we have about 2 minutes left, so I best wrap this up. I want to extend a heartfelt thank you to our presenters for making the time, for having this conversation and for sharing. So on behalf of everyone listening, thank you. And then a bit of housekeeping to follow up with. The recording of this meetup will be available on YouTube soon. probably within the next 12 hours. So look out for the link in your inbox. We'll email it out to all the attendees and presenters. It'll also be publicised on social media, so please share with your colleagues and anybody else you think may be interested in the subject matter. And finally, to all the attendees, thank you for joining us. There are 4 more virtual meetups that you are welcome to join in on as well. So in less than 24 hours time, we'll discuss biodiversity and climate change. And then next week, we'll be discussing water quality, then land degradation, and finally agriculture and poverty alleviation meetups. So we hope you can join us all then. Until then, goodbye.